Badge readers blinked and then nothing. The lobby fills up, the elevator status goes dark, and the front desk radio is a string of can't get in calls. For the building team, the question is instant. What breaks if the cloud goes down? Welcome to Built, Wired, and Secured. I'm Alex Morgan. Today we're talking about that exact moment when the cloud your building relies on goes quiet and what owners and operators should actually do about it. Joining me is Michael Harrington. Michael, what's that first minute look like on your end?
Right away, you get phone calls and radios pinging. Panic sounds, basically. The immediate triage question is always, can people get in? Are life safety systems still reporting? Do critical contractors have local access? From an operational standpoint, that first half hour is about preserving safe, predictable access and keeping teams working while you figure out whether this is a network hiccup or a vendor outage.
Right, so the crisis becomes a series of quick checks. I want to slow us down for listeners. What patterns create that fragility in the first place?
You usually see three common patterns. 1. SaaS management portals, the vendor's dashboard where rules and credentials live. 2. Cloud-mediated device control, devices that phone home for configuration or commands. 3. Analytics and telemetry pipelines that centralize logic in the cloud. Combine any two, and you already have failure modes that cascade.
Wait, stop there. Give me a quick, concrete example where that combination actually caused a real problem in a building.
Sure. An access system that stores badge rules in the cloud but lets readers authenticate locally will work when the cloud is down. But if the vendor also pushes credentials from the cloud at shift changes, a cloud outage during a morning turnover can lock out new hires. The rule sink is the hidden fragility.
Got it. Hidden sink points. So vendors like cloud-first models because it lowers support costs and speeds features, but that convenience can become a single point of failure.
Exactly. The cloud gives centralized visibility and remote troubleshooting, which is valuable. The question for owners is, which cloud functions are mission-critical and which are conveniences you can tolerate losing for a defined window? That distinction should drive contracts and operations.
Let's make this practical. Where should owners draw the line between convenience and resilience? Give me specific guardrails.
Start by categorizing systems by impact. Label each as critical, important, or amenity. Critical systems, life safety, core access for tenants and emergency responders need local control and local logging. Important systems get hybrid modes and defined failover times. Amenities can be cloud first. Those categories then inform SLAs, acceptance tests, and budget priorities.
Okay, but I want to press you on cost. I get pushback. Owners will say, we don't have the capital or staff to maintain local controllers. That's expensive. Convince me the fallback is worth the budget.
Fair challenge. Do two things. 1. Pick one critical system and make it your pilot. Implement a vendor-supported local fallback rather than buying a whole new infrastructure. 2. Use contracting levers. Require the vendor to demonstrate fallback in your environment and add a measurable recovery expectation. For example, less than 30-minute failover to local control. The incremental capital is small compared with tenant downtime and emergency labor costs.
When you say require the vendor to demonstrate, what does that look like during acceptance testing?
It's a scripted scenario. Simulate a cloud outage, switch devices to local mode, verify authorized users can still badge in, confirm logs are written locally, and measure time to functional recovery. If the vendor can't show that in your network, you either negotiate compensating controls, redundant gateways, on-site controllers, or you push the date for handover until it's proven.
Got it. I want to hear two concrete cases you've seen where cloud dependency became an operational headache and how a simple mitigation helped.
Case 1. An office tower whose access control relied on a cloud identity service. One morning, the identity service failed during a tenant shift change. Tenants couldn't badge in, the lobby was overwhelmed, and contractors couldn't access critical floors. The team had an undocumented local master key mode that nobody had practiced. They activated it, and after awkward coordination, restored access. Afterward, they configured an on-site authenticated keypad fallback, documented the process, and ran a test. Recovery time dropped from hours to under 30 minutes.
And the second?
Case 2.
A campus HVAC analytics platform stopped accepting telemetry for 48 hours. Automated set point changes queued in the cloud and never executed. Temperatures drifted and occupants complained. The mitigation was straightforward: local fallback schedules on controllers and a quarterly blackout exercise that validated the schedule behavior. After that exercise, drift was predictable and escalation clear.
Those are helpful. I want listeners to leave with a concrete checklist, not just principles. Can you run through a measurable one we can use this week?
Start with 5 items you can act on immediately. 1. Inventory. List every system with a cloud touchpoint and tag each as critical, important, amenity. Target: finish this inventory in 30 days. Example: access control equals critical, tenant analytics equals amenity. 2. Verify offline modes. Confirm what works locally and for how long. Test at least a 24-hour window and aim for less than 30-minute failover to local control. 3. Acceptance tests. Include cloud failure scenarios at commissioning. Require vendors to demonstrate them in your environment before handover. 4. Run exercises. Schedule quarterly blackout drills with clear roles, communications, and documented outcomes. 5. Playbook and escalation. Document who calls whom, where local logs live, and tenant notification templates. Make the playbook a living document.
Quick interjection. For organizations with limited staff, what's the minimum viable approach to the checklist? What should they prioritize this quarter?
Prioritize inventory and 1 exercise. Finish the 30-day inventory, tag critical systems, and run 1 tabletop or simple blackout drill for a single critical system. The exercise will show whether your documented fallback actually works and where you need vendor help. That's the highest return for the least ongoing staff time.
One more tough question before we go. What if a vendor resists demonstrating failover or pushes that testing as extra billable service?
Then you use procurement and O&M levers. Insist failover demonstration be part of commissioning deliverables or require a documented compensating control. For example, a redundant gateway or a vendor-supplied emergency access method included at no extra cost. If the vendor won't provide that, negotiate financial protections or plan for a different integration approach. This is where you tie operational risk into contract terms, not legal advice, but practical risk management.
To wrap up, what's the single most important mindset shift owners need to make about cloud dependencies?
Treat cloud features as helpful extras unless they're explicitly tested and guaranteed for operations. Design for autonomous operation first, add cloud convenience on top, and make testing and vendor demonstrations non-negotiable.
Thanks, Michael. Practical, measurable advice. For listeners, take 1 hour this week to map your cloud touchpoints and schedule a single tabletop exercise. Small steps like that prevent big operational headaches. That wraps up this episode of Built, Wired, and Secured. Today, we looked at how cloud dependencies affect tenant continuity and building uptime, and why simple, tested offline modes and regular exercises matter. Thanks for spending a few minutes with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.